Linear regression is the basic machine learning algorithm, shows how a historical data is used to train and build using a model to predict or forecast the future. Let's take a simple, known, and commonly used example, house price prediction. In order to predict something continuous or numeric data like this, we use regression algorithms. So I'm going with a basic regression model, which is linear regression. So linearity is something called as straight line. Let me go with its equation of linear regression, which is wxi plus b equal to y. Here, w represents weights and b represents bias. It is basically a slope-intercept best fit line equation where the objective is to find the same. In general, weight and bias used for the line adjusting towards the independent and dependent variable. Let's see what is independent and dependent variables. Here in the house price prediction, it happens with the help of features like number of bedrooms, location, square feet, etc., which act as a independent variable, and price of a house as dependent variable, which is your target. In this simple linear regression, let's take one feature, square feet. So it is called as univariant linear regression. If I'm taking all these features as an independent variable, then it is called as multivariant regression. X is your square feet and Y is your target, which is price. And plot the values as per the slope intercept equation, wxi plus b equal to y. X1 is a square feet of your first row value, and it goes till xi, the ith row. You will get a straight line. From that, you can see the prediction by taking x pointing to a y. For example, square feet 255 cost me $500. If I need to check the line is perfect or not, I can use metrics like mean square error to compare actual and predicted values so that I can measure the accuracy of the model. If the accuracy is poor, I can increase the training epochs or feature engineering to improve it.